Let's use the concept of electrical field lines here. If you're unfamiliar with the concept, you're advised to watch the lecture on electric fields first. An easy way to understand the inverse square law is to remember that a common way to illustrate the strength of the electric field at a point is by how many field lines pass through a unit area around that point. Now let's imagine drawing a few spheres of different radiuses, all centered around the charge. Since the number of field lines passing through each sphere is the same, but the areas of the spheres are different, the electric field strengths are different. The area of a sphere is given by 4 pi r squared. Since the number of field lines are the same, the field strength is inversely proportional to the area of the spheres. In other words, proportional to 1 over r squared. This shows an easy way of conceptualizing how the 1 over r squared factor comes about. In fact, the argument I've given is a simplified version of an actual way to obtain Coulomb's law from a more advanced law in electrostatics called Gauss's law. However, it should be noted that this is not the reason we know that there is a 1 over r squared term in Coulomb's law. That was determined by experimenting with charge balls over many distances. This is simply a way of understanding the 1 over r squared factor.